Now, the real vapor compression cycle can also be plotted in a pH diagram, and it's even more handy because we are often looking for the specific enthalpy, and that's the x-axis, and also we have two specific levels of pressure, low pressure and high pressure, and the pressure corresponds to the y-axis, so it's easier to plot the characteristic thermodynamic states of the working fluid in this diagram, and also it's easier to read the specific enthalpy that we will need for the energetic analysis of the cycle. So first, point A, the inlet of the compressor, it's defined with the superheating that we have from the evaporation temperature. So the evaporation temperature, we can look for this iso temperature line, and that would be T evap, like this. And if we know the amount of superheating, so for example 5 Kelvin, that would correspond to this difference of temperature. And we can find the isothermal line that corresponds to the temperature of point A. Then the cross-section, the crossing with the low pressure isobaric line corresponds to point A. Then next step is plotting point B, the outlet of the compressor. So in order to find point B, we'll first look for point B is that corresponds to the outlet of the compressor we would have when compressing from point A, but with an adiabatic reversible compression to the high pressure. So you can look for the isoentropic line crossing point A, so that's little s index A, and the cross section with the high pressure isobaric line corresponds to point B is. So on the x-axis you can read the specific enthalpy of point A. You can also read the specific enthalpy of point B is, and once you know these two specific enthalpies, using the isentropic efficiency of the compressor, you can calculate the specific enthalpy of point B real, and in that case you look for this specific enthalpy, and when it crosses the high pressure, it corresponds to point B. Then across the condenser, the working fluid is entering at point B. Its temperature decreases at constant pressure to the condensation temperature. So this isothermal line corresponds to the condensation temperature. And so then the working fluid is fully condensed and slightly subcooled with a given subcooling. So if you know this subcooling, for example 3 kelvins, you can look for the isotemperature line which corresponds to this delta T of subcooling. And the point which crosses this isotemperature line and the high pressure isobaric line corresponds to point C, the outlet of the condenser. Then between point C and point D, across the expansion valve, the specific enthalpy remains constant, so you can go directly vertically down on this kind of diagram. So this is the specific enthalpy of point C and also of point D, and point D is where this P line crosses the low pressure, so that's point D. And then finally, across the evaporator, the fluid enters in D state, so mostly liquid but a little bit vapor, and the fluid evaporates completely and it's slightly superheated,